Alright, when we go from names to formulas in binary, what we want to do is look for two things, binary. So in this case I recognize phosphorus, and sulfide I recognize the IDE means it's not a polyatomic. They tend to be ITE or ATE. This is IDE, so that tells me that it's just sulfur. The other thing I sometimes recognize is if I see pentas or dis or tris, that's only ever used in covalent binary. So I go right to covalent binary in my head and say, okay, this just tells me what everything is. So I have phosphorus, and I have two of them, di. I have sulfur from sulfide, and penta is 5, so I have 5 of them. So it actually tells me my name, 2 phosphorus, 5 sulfur, or my formula tells me my formula, and I can write it straight there. Very convenient, but it's not used very often, so don't fall in the trap of naming everything with dis and pentas and tris, because we don't use them very often. The next one has one name first, the IDE ending, so this is my hint that this is going to be my binary compound, but this beryllium is a metal, and metals, we don't use monoditris and ionic. We actually have to do some work. So beryllium and iodine, I recognize what's there, but I don't know how many of each. Beryllium's group 2, so it's 2 plus ion. Iodine is group 17, so it's 1 minus. But 2 pluses and 1 minuses don't even out. They don't cancel. They don't balance, if you will. And so we need to have another 1 minus iodine. So this would be how my ions would balance. And then when I write my final formula, it's BeI2. So I need 2 iodines for every 1 beryllium. So beryllium iodide has a formula of BeI2. You have to do that for any time you have binary ionic. You have to find out the charges and balance them out so that they're neutral. Well, there we go. Magnesium is a metal. Nitrogen is a nonmetal, so this is going to be ionic. Mg is also group 2, just like beryllium, 2 plus. Nitrogen, what is that, group 15? So it's going to be 3 minus charges. It needs to gain 3 electrons in order to be full octet. And so we got to look at these two. And this one doesn't balance out in my head quite as quickly. I know I only have 2 pluses and 3 minuses, so I think I need another magnesium 2 plus here, which makes 4, but then there's only 3 minus, so I would need another nitrogen. That makes 6 minuses and only 4 pluses, so I think I need another magnesium. 2, 4, 6 pluses, 3, 6 minuses, I end up with Mg3N2. Now, I don't like the crisscross rule, but for some people, when I started right here, may have been taught that if I take the number here and write it as the subscript there, and the number here and write it as the subscript there, I'm going to end up with my formula, which works pretty well, except you sometimes need to reduce. And it doesn't work too well going backwards, trying to use that to get the name from the formula. So I don't like doing it. I like just figuring out what my charges are and keep balancing until everything works out, because I won't make any mistakes. I don't have to worry about reducing. I'll always end up with the right formula. But that's there. If that makes sense to you, by all means use that. Last one, sulfur dichloride. Sulfur dichloride, I recognize sulfur and chlorine. I also recognize this di here, so this would be monosulfur, but we always drop that on the first one, so it's sulfur, di means 2, sulfur dichloride, and we get SCl2.